Okay, let's look at this question. Now, remember in the last podcast I stated that we're not going to clean it up. What I meant by cleaning this thing up is putting it into y equals to mx plus b form. Well, I'm not going to do that yet. I will in this podcast, but I'm not going to do this right away because I want you to see why we leave it in this form. Why do we leave this in such an ugly kind of algebraic mess? Because I want you to see exactly where everything is. First thing that this question says is state the slope. Well, you know and I know that that's the slope. The slope is minus 5 over 2. But it also asks you, what's the point? Now, if we would have cleaned this up, we would have had the intercept, and we wouldn't have been able to figure out what the point was. This asks you specifically, what are the coordinates of the point? And you remember, this is y minus y1 equals to mx minus x1. What does this mean here? Well, look, this has got to be our y1. This has got to be our x1. Look at it. How do we figure this out? What are the actual coordinates? Well, remember, these guys are minus to begin with, right? Both of them are minus to begin with. So think of the value that x1 has to be in order to keep this to a minus. Again, let me restate that again. Think about what the value of this guy has to be in order to keep this a minus. Well, the only thing that works is positive 2, because if it was a negative, look, you have x minus, if it was a negative, look what would happen. The negative would have made this an x plus 2, and it's not. It's an x minus 2. So that had to have been a plus 2. Look again. Because if I did that here, look what happens. Watch, watch, watch. This is an x minus x1. If I use the value of 2, look at this. It maintains that negative there. So that idea of flipping this sign is what's going to mess people up. Look again right here. Look again right here. There's a minus 4. Same thing happens right here. All right, so this would have to be a y minus, that would have to be a 4. So the coordinates of y1 must be 4. Because if it was a negative 4, it would have flipped the sign. Aha! All right, so now let's keep on going. So what are the coordinates of our point? The coordinates of our point then are 2 from here, comma 4 from here. See it? Excellent. So now, using that, it says, draw the graph. Well, simple. Remember, when we draw a graph, all we need is a slope and some point. We've always been using this beautiful point. We've been using the intercept. Well, so what? This is a point on the graph. Just go from there and draw the slope. Okay, so 2, 4 is this point right here. There's 2, there's 4, there's the point. Boom. The slope is down 5 over 2. Remember, slope is rise over run, so down 5. So if we go down 5, we go 1, 2, 3, 4, 5, and over 2, 1, 2. So there's our line. Looks very, very much like that. Okay? So again, there's your down 5. There's your over 2. Beautiful. Okay? And your start point there, which is 2, comma 4. Now, check this out. Look what the next step says. The next step says verify using technology. Well, this is the first step, the first time you've ever seen this. Verify using technology. That means dun, da, 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 using your graphing calculator. Now, the cool thing about your graphing calculator is this. It has a button right here that says y equals 2. And when you press that y equals 2 button, here, I'll go from the main screen again just to show you. Okay, so here's the main screen. Okay, boom, that's the screen there. If you press y equals 2, this shows up. This gives you a potential of putting 9 different equations all on one graph. Oh my goodness. Well, a couple things you have to do in order to do this properly is you also need to do this button here, which is called zoom. And then if you look way down here at 6 and almost down to it, okay, do you see zoom 6? Zoom 6 means zoom standard. And what it's going to do is it's going to standardize your graph. And you looked at all the graphs that we've done, we've always done this to have 10 going this way, 10 going this way, 10 going this way, 10 going this way. But I never called it that. I never called it what it's actually called. That's called zoom standard. Okay? So this gives you 10 going this way, 10 going this way, 10 going this way, 10 going this way. So it should give you a nice looking graph. Now, let's look at this equation then. The equation here from the original says y equals 2. Oh, wait a second. Look at that. It's not y equals 2. It's a whole mess. This is y minus 4. Okay, so what do I got to do? Well, what you have to do is, yep, you're going to have to put it as y equals 2. Oh, man, does that mean I have to do algebra? Yep. Okay, so here we go. Let's do some algebra. First things first, you know and I know we have to distribute this to here and to here, giving you minus 5 over 2x minus 2 times, yep, minus 5 over 2. But look how pretty this is, because if you put it over 1, you know that this guy becomes minus 2 times minus 5, which is positive 10, over 1 times 2, which is 2, which works out to be plain old 5. Yeah, that looks like a 0. There we go. Plain old 5. So what you have here then is, if we clean this up a little bit, we have y minus 4 equals 2 minus 5 over 2x plus 5. There we go. Now, simplify it even a little bit more by adding 4 to both sides, and look what you got. Y equals to minus 5 over 2x plus 9, which is y equals mx plus b form. And if you look at that, lo and behold, my intersect is, in fact, there it is. It is, in fact, at 9. Now, how do we put this into our calculators now? Well, okay, let's do it. Here we go. Calculator says, I'm going to bring it over here so that you can see this original formula. Go to your y equals 2. There's your y equals 2. You have, and whenever you do fractions on this calculator, make sure you do it in brackets. So here we go, brackets. Negative 5 over 2. There's the bracket. Now, where's the x? The x is right here. There's your x value right here. And that's what you would touch in order to get an x in your calculator. So x, see how it popped up? Beautiful. Plus 9. Now, check it out. It should look like the graph that we plotted. And lo and behold, wow, cool. It does a beautiful representation of what we have there. So this is just an awesome podcast teaching you a whole bunch of stuff about your slope and point formula. It also teaches you a whole bunch of stuff about how to use your calculator. So I'm going to do part 2 right away, which is going to take another question and do exactly the same thing. Stay tuned.